In this recording sizobe discussa or siphendula i-question on ama-electric circuits from this question 10 yaka November 2019. In the description box, as usual, kunama links for other recordings for the question paper, as well as a link to another channel engicreatile for ama lessons. Please check it out. I would appreciate it now we are subscribed to the other channel as well. It's called Virtual Master Classes. I'm not answering our question papers on the other channel. I'm giving our lessons. So check it out now. Now, back to question 10 way to get. But 3 resistors, 3 ohm, 4 ohm, 6 ohm, and a bulb are connected in a circuit as shown below. Initially, all the switches S1, S2, S3 are open. The internal resistance of the battery and the resistance of the conducting wires may be ignored. So, grade 12, we don't ignore the internal resistance of the battery. Ngoba sikhuluma nge-EMF, university level. The resistance of the conducting wires is also not ignored. It's also not ignored, provided that now you study physics at the university level. Especially naso ukhuluma nge-electricity, then uzoyidiscussa this part, right? So since it deal nama ohmic circuits, or ama circuits are open Ohm's law, like 10.1, which the law states that the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. So once the temperature increases, once the temperature increases, you get a non-ohmic circuit. So the laws ga ohm akasa apply lapho. So that's when we need to take into consideration ama resistance in the conducting wires again, right? So yeah, but usilapha siyakungawari ngalo. When you ignore internal resistance of a battery as well as the conducting wires resistance. Now this is Ohm's law. Switch 1 is now closed. Ngifunda le statement list. Switch 1 is now closed, and the voltmeter and ammeter readings are recorded. The voltmeter and ammeter readings when both switch 1 and 2 are closed are then recorded. So sithi switch 1 siyamvala, siya recorder i-voltmeter reading the ammeter reading. Then we do the same for switch 1 and 2 when they are both closed, as well as for switch 1 and 2 and 3 when they are all closed. All 3 of them are closed. Then now my readings wakhona as well. Yes, and then the results are obtained as shown in the table below. Bese ku 10.2 what is explain the increase in the ammeter readings as more switches are closed. As more switches are closed. Okay, let's do this. This is Ohm's law. This is Ohm's law. Nangivala switch 1. Switch 1 yamvala. Ngiba ne 3 ohm resistor seyiba live on this circuit. So meaning nangivala switch 1 sengiba ne current in the circuit, right? And then current yami yo flow la is a so, and then it flows through the 3 ohm, is a so, it passes through the bulb, right? So it means that the 3 ohm and the bulb are connected in series. Yes, are connected in series. Nangivala switch 2 nyamvala current yami yomuva lana ibuye ingene nangapha ke. So it means that nginani sengi-introduce a parallel. Okay, sekuba ne parallel connection ke manje, and we know from theory ukuthi a parallel connection has less resistance than a series connection. So initially nangiva switch 1 nginani ngine series connection. Nangivala switch 2 sengiba nane parallel connection and a series connection. This bulb and this 3 and 6 they are connected in series, but this 3 and 6 they are connected in parallel. I hope it makes sense. This and this are in parallel, but this 3 and 6 are in series with this bulb. Uyabona? Bheka ke manje. So initially nangivala switch 1 ngibanani ne series connection which has more resistance. Nangifaka switch number 2, boom, sengithola a parallel connection with 3 ohm ke manje. Uyabona? Nangiba ne parallel connection, what happens to resistance? It goes down. Decrease. Nangivala switch 3 ke manje, another parallel connection is being added, so resistance yenzani, it decreases even further, and we can see that resistance is inversely proportional to current. So whenever resistance it decreases, what happens to current? It increases. Yes, it increases. Increase. So therefore singathi la but isi explain so singathi more resistors are connected in parallel as the switches are closed. Therefore the effective resistance of the circuit decreases. More resistors are connected in parallel as more switches are closed. Therefore the effective resistance of the circuit does what? Decreases, and the current does what? It increases. It increases. Maybe that's the reason why I provide 10.3, 10.3.1, but this is calculated the resistance of the bulb. So begagela, this ammeter reading is for the whole circuit. Yes, it's for the whole circuit. A parallel connection, it's the only connection a divider in a current. As I was explaining, this parallel connection is in series with this one. So a series connection, it doesn't divide a current, but it only divides what? A potential difference. So this reading is it's actually the potential difference across a bulb yet, and then this current is for the whole circuit. Ngoba a current in a series connection, it's not divided. The current flow la parallel connection is the same current flow la as well as the whole circuit, right? Lana ngifuna a resistance for the bulb. In order to calculate the resistance for this bulb, sifuna R wala. In order to calculate to R, uzodinga the potential difference across this R, which by the way I'll explain in a moment. And then I also need the current across this R. I do have. I'll explain in a moment. So the question lega 3.1, 10.3.1, it doesn't matter to sebenzisa mapha ma values la. Ngoba this voltmeter reading, it's for this bulb R, and then this current, it's also for this bulb R. So sizothikela, the resistance is equal to V over I, which is equal, it doesn't matter to spanisa ipila. I can even prove this. So it's V over I, mina ngizosebenzisa switch 1 when switch 1 is closed. 4.8 the voltmeter reading yaga bulb R. Voltmeter reading ka bulb R. Okay, I think la instead. So R, it's V over I equal to 4.8 divided by 2.4. This is equal to 4.8 divided by 2.4 equal to 2. Is equal to 2 ohm. We can do for switch 1 and 2 when are closed, so it's 6 divided by 3 total 2. When all three switches are closed, 7.2 divided by 3.6. Now I answer it, it's 2 as well. So it doesn't matter to 7 which one. 10.2 3.2 potential difference of the battery ke manje sifuna the potential difference of the battery. Okay, lana it also doesn't matter ukuthi usebenzisa which readings, doesn't matter ukuthi usebenzisa which readings, but it's important ukuthi understand ukuthi what is connected to the circuit. So okay, since ngisebenzisa switch 1 la phezulu S1, let me also use switch 1 nala ngaphansi. Bheka ngifuna the potential difference of the battery. Yes, of the battery. Ngifuna the potential difference of the battery. So, na into engizoyenza ke. Ngizodinga the current for the whole circuit. Ngenzeni? Ngicalculate as well as the okay, bheka. R is equal to V over T. This is Ohm's law. But I manipulate the equation so that ngibhale as I times R equal to V. Since ngifuna the potential difference for the battery, which is the same as saying the voltage for the total voltage, or the voltage for the whole circuit. So now we're ngifuna the voltage for the whole circuit, the total voltage. I also need the total resistance. I also need the total current. I also need the total current for the circuit. Bheka ke manje. The current for switch 1, it's the current, it's this total current. And then now ngifuna ukuyicalculate. In order to calculate lo V, ngizodinga ukukcalculate the total resistance for the circuit. So nangivala switch 1, the 3 ohm resistor is connected in series with this 2 ohm bulb. So therefore the total resistance kuba simple with me calculate manje. So kuba R tot which is equal to 3 plus in series. Lena it's in series to this one. So for the bulb, this 3 ohm it's for this 3 ohm resistor, and then plus 2 ohm for the bulb. 5 ohm. Therefore V tot, the total voltage for the whole circuit, or the voltage for the battery, the voltage for the battery and the total voltage for the circuit must be equal. So therefore COT I, which is 2,4, since ngiyuza ubani switch 1, times the total resistance, which is 5. Let's multiply 2,4 times 5 is equal to 12 volts. So even if you sebenzisa switch 1 and 2, you should get 12. Switch 1, 2 and 3, you should get 12 as well. So 10.4, what is defining power? Well, power is not defined as the term. Define the term power. Power is the rate at which work is done. Like this one. Where's the term? Rate at which work is done. Rate at which work is done in the circuit, right? And some charges is a move around the circuit. Okay, let's say le resist na bulb. Senze example ngebulb. Le bulb nalikhanya leli, ama charges asuka a deliver a transfer energy, so they are doing work. They are doing work. That's why le bulb likhanya leli. They are delivering ama charges. They are delivering energy to the bulb. So that's why likhanya. So how fast are the charges doing work or delivering energy? That's the concept of power again. Bese but is calculated the power dissipated like 10.5. Okay, what am I thinking? Okay, since so let's erase lana and do 10.5. Okay, 10,5. Let's see. What is calculated the power dissipated in the 6 ohm resistor when only switches 1 and 2 are closed? Sivala switch 1 and 2. Ne? Sivala switch 1 and 2. And then as pay attention to the voltage for now. So lana about 6 volts, and then the current about 3 ohm. So 3 ohm. But for now, let us focus our attention la. This bulb and this 2 resistors are connected in series, but lo 3 na lo 6 they are connected in parallel. A parallel connection is what is a current divider, but the potential difference lana remains constant. The potential difference for 3, the potential difference for 6, it's the same, as well as the potential difference across this parallel connection. So there are several formulas as well for calculating a power. The first one is P V squared over R, sibeno I equal to V over R, and sibeno no bunch. OHM'S law. No man. P equal to VI, and then sibeno PI squared times V. I squared lapha. Yeah, I think I 3. 1, 2, 3. So therefore, in order to calculate the power, udinga a potential difference as well as a resistance. So for the 6 ohm resistors, for calculate the power, I do have a resistance. Now having considered the formula number 1, this is 2, this is 3. Now having considered the formula number 1, resistancing now. Yes, I do have ubani 6. So now the next challenge is to find a potential difference across 6. So start to calculate as I told you the potential difference across the battery is 12 volts. If ever the potential difference across the bulb is 6. Since in a series connection potential difference is divided, parallel connection current is divided but the potential difference remain the same. Keep that in mind. In a series connection potential difference is divided or is shared, right? So if lanang na 6 volts, it means lagu parallel connection you ban how many volts? You ban 6 volts as well. So therefore as the potential difference across the parallel connection, let's say Vp is equal to V for a battery minus V for a bulb. So is equal to V battery, it's 12 minus 6 is equal to 6 volts. So therefore I can calculate the power again with the P equal to V squared. Make sure go to a Bali formula ne. We value substitute directly. We then substitute afterwards. 6. Answer is equal to 6 watts. Because of now Ibala is also a mark. Now for 10.6 they ask us a question: how will the brightness of the bulb be affected as more switches in the circuit are closed? Right only increases, decreases, or remain the same? Okay, should I give the answer or explain it? Okay, let me say they increase. Brightness is or increase. I think it would make sense to say our answer lies lanagu 10.2. Explain the answer to question 10.6. As more resistors are connected in parallel, usakhumbula, the effective resistance decreases and the current does what? Increases. So more charges are flowing kule bulb le. More and more charges are flowing, so therefore I deliver a lot of energy la. So therefore i-brightness yenzani nangivala switch 1 yoba dim nyana, ngivala switch 2 yenzani iba bright nyana, nangivala switch 3 iba very bright, uyabona, iba very bright. So i-answer yethu it somehow lies lapha ku 10.2, yabona, it lies lapha kulo kanje ku 10.2, or you can use i-formula power where power is directly proportional to, especially this one, this one, power is directly proportional to what? To current. So the more current increase, what happens to power? Power nayo increase, meaning more charges are delivering in energy, as I was explaining. So yeah, question 10 uphelela khona la. I hope we enjoy. I hope we told some value out of this video today. In the description box kunamanye videos ongawabukela for this question paper. There's also a link to another channel for our lessons. Check it out as well, guys. So yeah, thanks for tuning in. Makhohlwa ukulike, ukushare, ukusubscribe, and liking the video, of course. So for now, asibonane on the next one. Bye bye.